This is a new education facility of Creative College located in Bristol, UK. The existing Creative College currently provides education for 1,500 students aged from 3 to 18 years old, with a 25% growth of students in next few years. The new campus needs to meet the current and future needs of the school. The new building facility aims to provide a supportive environment for students. And also, school opened up facilities for parents to engage into child's life and their personal growth. Bristol, located in southern England, with a mean annual temperature of 10.5 degrees Celsius. The annual sunshine hour is approximately 1,500 to 1,800 hours per year. The cold season lasts from November to March, with an average daily high temperature below 9 degrees Celsius. So space heating strategies should be considered in this project, with 1,893 degree days for this area. The total set area is 100,000 meters square, and ground floor area for building is 25,000 meters square. The surrounding architectures are 2 stories, which will not obstruct daylight of buildings in campus.
Our concept design is to connect the different functions by the community space, which are common rooms, playgrounds, and activity space. For the layout, the existing trees are conserved and used as zone partitions, which are separated to the public facility zones for students and parents, school zone, and future expansion zone. The circulation path and landscapes are parallel to both building and side edges to connect them together. Water can be stored in these ponds. As the sun path of Bristol is oblique to the south throughout the years, all classrooms are facing south to optimize the interior daylight. Distance between buildings is for avoiding the shading of each other, and they are connected by the bridge, which is also used as a community space. For the classroom unit, the south-facing facades are sloped and shading itself to avoid high-altitude sunlight in summer instead of using shading device. Light shelves are used to reflect and diffuse the daylight into the middle of the rooms, and the glazing on the top of the partition provides some light from the corridor to the end of the rooms. As a result, the average daylight factor stimulated by the side builder is 3.2%, and the uniformity is about 6 times higher than a conventional classroom.
We use shading devices in most of the buildings, like exterior shading devices attached to the building and also the extension of the building envelope skin. The horizontal form for south-facing facade is to reduce glare by partially block occupants' view of the too bright sky, and the vertical for east and west facade, mainly the library, catering, and the pool, to block the early morning and late afternoon low sun. The fin is mostly dimpled metal sheet to allow some illuminance penetration. Skylight is also mostly used in long-span buildings like the library, catering, and also the sports complex.
The external wall is insulating concrete formwork. ICF is an energy-efficient building method which creates insulated structural walls for residential and commercial buildings. The wall consists of concrete, tongue and groove, steel ties, furring strips, and polystyrene, which totally form the U value 0.15 watts per square meter per Kelvin. The roof consists of 5 layers to achieve the total U value 0.15. The double-layer low-E coating glass with argon filling achieved 0.8 watt per square meter per Kelvin.
For our project, the specific heat demand is averagely 74 kilowatt-hour per square meter per year. The value of our project is specific heat demand at averagely 9.3, which is lower than 15 kilowatt-hour per square meter per year. And the swimming pool is a little higher at about 20, and the primary energy demand in our project is averagely 74, which is also within lower than 120. The PE is at 131, which is a little higher than the Passive House benchmark.